these are another example of finding the derivative of function using the properties of derivative of algebraic function. For example number 5, the given function f of x is equal to 3 over x squared, wherein instead of using the quotient derivative, you can express the given function as 3x, and then this is raised to negative 2. Then instead of using the quotient derivative, you can now apply the power derivative, wherein you can bring down the exponent and then less 1 from the exponent. So then the derivative of the function f of x is now f prime of x, and this is now equal to negative 6, because bring down negative 2 multiplied by 3, that will be negative 6, and then less 1 from the exponent, so that will be negative 3. Then the derivative of the function is equal to negative 6x raised to negative 3. Now for example number 6, this is y equal to the quantity of x plus 2 times the quantity of 2x minus 3. Now in this example, there are two ways or two methods. First is you can simplify the function as distributing the given terms. So from the given function, it is now simplified as y equal to 2x squared plus x minus 6, wherein we can multiply or distribute the terms from these two product form. And then instead of using the product derivative, you can now use the power derivative. So this is simply the derivative of y as y prime is now equal to bring down 2 times 2, that will be 4, and then less 1 from the exponent, so that will be x, 4x, and then derivative of x with respect to x is equal to 1, and derivative of negative 6, which is constant, is 0. So finally, the derivative of the function, which is y prime, is equal to 4x plus 1. Now another method is, without simplifying it, just simply use the product derivative, as the first expression will be considered as the u, and then the second expression will be considered as the v. So this is simply as example of the product derivative as u. We can consider the x plus 2 as the u, and the quantity 2x minus 3 as the v. And then since the product derivative has a formula that this is simply for the function y is equal to uv, then the derivative of the function y as y prime will be u times derivative of v plus v times derivative of u. So if we will consider the u as x plus 2 and the v as 2x minus 3, so then this is simply the derivative of the y with respect to x, or simply y prime, is the u and then times the derivative of 2x minus 3 plus the v times derivative of x plus 2. So you have to input as d in order to consider that we have to find the derivative of this expression. So finding the derivative of 2x minus 3 is now equal to 2, and then plus 2 quantity 2x minus 3 times the derivative of x plus 2 is 1. And then simplifying, distribute the 2, so we have 2x plus 4. On the other term, we have 2x minus 3, and then combining similar terms, we have 2x plus 2x, and that will be 4x, 4 minus 3, and that will be 1. So we can have that the y prime is equal to 4x plus 1, which is also the same answer in method number 1. And then the next example is another example of product derivative, which is this time we cannot simplify it. So instead of another solution, we can only apply the product derivative here because we cannot simplify the given function. So the given function y is equal to square root of x plus 2 times the quantity of x minus 2. Then we can consider the square root of x plus 2 as the u and the quantity as the v x minus 2. Then applying the product derivative, we can now have the derivative of the y, which is y prime, is now equal to the u square root of x plus 2 times the derivative of the quantity x minus 2 plus the v x minus 2 times derivative of the u, which is the square root of x plus 2. And then finding the derivative of x minus 2, that will be equal to 1. And then on the other hand, on the second term, the derivative of square root of x plus 2, this is by means of the power derivative. Square root means raised to 1/2, so bring down 1/2. And then the quantity x plus 2, from the exponent 1/2 minus 1, so this is now negative 1/2, and then multiplied by the derivative of the quantity again, which is equal to 1, because the derivative of x is 1. And then simplifying, we have it here, multiplied by 1, so this is still square root of x plus 2, and then the quantity x minus 2 times the square root of x plus 2, because this one is raised to negative 1/2, so we can bring it down as denominator, so this is now a positive square root of x plus 2. And then the 1/2 now will be as denominator as 2. And then in order to simplify this, get the LCD, because 1 is a rational, so get the LCD, which is the LCD, the least common denominator, is the denominator of 2 square root of x plus 2. And then simplifying, the LCD divided by 1, because the denominator of this, the first term, is 1, and then multiply the numerator of square root of x plus 2, and that will be 2 times the quantity of x plus 2, because the square root of x plus 2 times the square root of x plus 2 is simply x plus 2. And then the next term, the LCD divided by the denominator, so this is 1, multiplied by numerator, so this is now x minus 2. And then simplifying the numerator, we can distribute the 2, so this is now 2x plus 4 here. And then plus x minus 2. Combining similar terms, you have 2x plus x is 3x, and then 4 minus 2, that will be 2. And this is our final answer as 3x plus 2 divided by 2 square root of x plus 2. So the derivative of the function as y prime is equal to 3x plus 2 divided by 2 square root of x plus 2. And then for the last example, the given function is y equal to x squared over the quantity x plus 1 raised to square. So this is an example of quotient derivative, wherein the numerator will be the u and the denominator will be the v. Now, recalling or consider the formula for the quotient derivative, that this is now equal to the square of denominator, and then in the numerator part, it should be denominator times derivative of numerator minus numerator times the derivative of the denominator. And then applying the formula, so then this is now the square of the denominator, so this is x plus 1 raised to square, then raise another square. And then in the numerator part, the denominator, x plus 1 raised to square, times derivative of the numerator of x squared, minus the numerator x squared times the derivative of the denominator, x plus 1 raised to square. And then getting the derivative of x squared by power derivative, and this is 2x. On the other hand, derivative of x plus 1 raised to square is by power derivative also, so we have to bring down the 2. And then from the quantity, raised to 2 less 1 from the exponent, so this is 1, and then derivative of x, and that will be 1. Then simplifying, we can factor out the common, which is x plus 1, quantity x plus 1. So factoring the quantity x plus 1 and the 2x, so common is 2x and quantity x plus 1. Therefore, the remaining on the first term now is the x plus 1. And then on the second term, the remaining is x when we factor the 2x and the quantity x plus 1. And then here, we can combine the x minus x, that will be 0. So remaining here is 1. Then we will have 2x times the quantity x plus 1 in the numerator. And then we can reduce the x plus 1 from numerator and denominator. So remaining here, this is now cube. Therefore, the final answer is 2x over quantity x plus 1 raised to cube. So this is your final answer, as y prime is equal to 2x over the quantity x plus 1 raised to cube.